Ms. Pauli Undesser is Director of Regulatory and Technical Affairs for the nonprofit Water Quality Association. She also maintains the title of Toxicology Manager for the WQA Gold Seal Product Certification Program and is the Technical Liaison for the Water Quality Research Foundation. Pauli holds a bachelor's degree in chemistry from the University of Illinois at Urbana-Champaign and a master's degree in biochemistry from Northern Illinois University. Here to discuss a new global approach to water treatment, please welcome Ms. Pauli Undesser.
Thank you, Bob. All right, so the last presentation after 2 full days of great presentations. Because of that, I have 2 main goals. The first of which, to keep everybody awake. So that's the first goal, and hopefully I will do that just by being a dynamic speaker and adding some really good content to the presentation and maybe a few pictures to kind of keep you in sync with the presentation as well. But foremost, what I'm really here to do is to actually go over the final barrier concept. So this is a new global approach to water treatment. Like anything that's new or emerging, it's actually something that's been around for probably 40 years, maybe 50 years, maybe even 100. But it's coming to the point where it's actually being used. There's been enough research to substantiate it and give it credibility, so it's actually coming into whether it's a national usage or a global usage. So today what I'd like to show is that point of use and point of entry devices are starting to be used on a global basis to provide safer water to more people. But we're also using it here in the States on a national basis to supplement what is happening with our central treatment or to actually help the central treatment with compliance itself. So this is something that is an initiative by the Water Quality Association, is to start discussions of this concept, to bring it into any discussions where water conservation or water efficiency is being discussed, because this concept may be something that can help us get away from thinking that every drop of water has to be drinking water quality grade. Only 1% is actually consumed. That means 99% is actually used for irrigation, fighting fires, and other usage that may just require utility grade, which still needs treatment. But for that 1%, let's look at polishing that 1% so that we can gain efficiencies in other ways. So just if you're not, if you don't know who the Water Quality Association is, I just put in a quick slide here to show that we are a not-for-profit international trade association. We represent the residential point of use, point of entry industry, as well as commercial and industrial. So we're talking about drinking water treatment. Today in the presentation, I'll go over kind of 3 main segments. Why? Why do we need to even discuss the final barrier concept? What is the final barrier concept? What do we use for it? What are the technologies? And then how? How is it currently being applied, or how can it be applied in the future to help us on our route to water conservation and water efficiencies? So to start off, I know in many presentations we've seen a lot of the reasons why, but I'm going to start off with some of the global reasons which may not have been brought up in some of the presentations the last couple days. Some of it is globally, we're talking about third world countries where we don't have central treatment. So we have poor quality source water, which we would have more likely in third world countries where we don't have source control as much as we might in the domesticated world. We also have storage that may occur in homes where you're collecting that water and it needs to be stored for periods of time. As we saw from Jordan in one of the earlier presentations, they get an allotment of water per week and they have to store that and use it throughout the week. That's something that here in the US we don't have to worry about quite as much unless we're doing reuse for potable or non-potable usage. Treatment of water consumed outside of the home. Again, in many third world countries, there may not be treatment outside of the home, or in some cases that may be the only place they do get treated water. And they also have distribution system intrusion, just like we do in the States, but they may have even worse cases of distribution system intrusion. Just to kind of give a perspective from the World Health Organization and UNICEF, they put out a joint monitoring report back in 2010, and it showed that 884 million people do not have access to safe drinking water across the globe, and 2.6 billion actually lack access to adequate sanitation. So this shows that there really is a huge scope out there for some type of water treatment technology that can actually provide safe drinking water to more people. There are still many, many people out there that do not have access to safe water like we do here in the US. 88% of cases of diarrhea worldwide are attributed to unsafe water or insufficient hygiene or lack of sanitation. So again, just one more reason that we should be looking at global perspectives here. I believe it was brought up earlier that, not 100% of waterborne pathogens can be removed 100% of the time conventionally. So even looking at in the US, we try the best we can at the central treatment, but if you have periods of stagnation, you're going to have waterborne pathogens that are growing. So there may need to be something that you look at the end of the line to give that final barrier of protection for safe water. Pathogens do grow in the distribution system. Chronic diseases are caused by waterborne and water-based pathogens. There is a widespread of occurrence of enteric viruses in groundwater. There's contamination in distribution systems. And of course, we always have to keep in mind the sensitive populations. So that's kind of a global perspective, but some of that comes over into the US perspective. One, we do have microbial contamination here as well. So a few studies that I've cited here show that about 35% of all municipal wells are contaminated with enteric viruses. About 8% of homeowner wells contain viruses. And 23% of small public groundwater supplies contain viruses. But besides that, then we can get into, in the US, again, we have some of the best drinking water in the world. So sometimes we just may want to look at a final barrier concept for what the consumer wants or what the consumer is demanding. And of course, as we know, one size does not fit all. Each consumer is going to have a different sensitivity for tastes or odors, or maybe just feel because they have different sensitivities on their skin. Later I'll talk about the MCL versus the MCLG. Some educated consumers will want to go as far as they can instead of just going to what is feasible. They want to actually remove all of the lead, not just leave some of the lead that is there. Again, hypersensitive populations need to be taken into account because they do demand a higher quality of water. Final barrier protection is good against things in the US that are unexpected issues. You may have water main breaks. Those happen all the time. And so something like a point of use or point of entry device may be able to help in those types of cases where you can't get to fix that water main break very quickly. Also, in certain cases, they may add extra chlorine to try to help with any microbial growth that comes with that intrusion. And there have been cases where people have sensitivities in their stomach lining because of that chlorine. So sometimes those people just may want to take out that extra chlorine that has been added for a taste or a sensitivity that they're having. Known issues, this also comes down to if you know that you have these water main breaks somewhere, you have leakages. Some cities are up to 30 or 50% of their water actually leaks, and whatever goes out, you have a potential of intrusion as well. So these are all areas that we can look at. Can final barrier be a concept to help provide safer water? Unregulated contaminants is another one. As we know, typically legislation and regulation takes a while to actually get into effect. So there are certain things that we're talking about. Again, some of these are emerging contaminants. We've been talking about them for 30 or 40 years, like endocrine disrupting compounds, pharmaceuticals, personal care products. They're still being researched. Is it something that is a health concern for humans? Is it not? There are some people that say, well, you know what? If it's hurting aquatic life, I don't want to be taking it either. So some consumers take that upon themselves to go that extra step to try to provide that final barrier so they do have safer drinking water. Other unregulated substances, some of them are nitrosamines, they're being looked at. Those are disinfection byproducts in most cases, and it's something that regulations haven't quite caught up to them. It may be something that consumers or municipalities want to take care of before those regulations get in place. Sulfolane is one that I threw on here. It's something that Alaska recently has been dealing with. It's an additive to oil refining, and they're finding it in the groundwater. So obviously there's a leak somewhere in their refining process, and this is showing up in the groundwater going to homes. So they actually approached WQA to try to help them because they had a product that would be able to remove the sulfolane, but they needed the testing and the certification and then the justification behind it that this could be used as a point of entry or point of use device to actually remove sulfolane to provide their customers with better water quality. So taking a step back just briefly for the EDCs and pharmaceutical removals, I just wanted to quickly put up here a slide by the Water RF study that was done in 2007. It shows a couple different columns of different treatments that were looked at for different endocrine disrupting compounds and pharmaceuticals, and I'm not going to go over it in detail. But basically what to notice is the green is where those technologies were considered good removal for those contaminants. The yellow is fair and the red is poor. So you can see the last column is where nanofiltration and reverse osmosis was found to be good pretty much over all of the contaminants that they were looking at. Whereas the other ones were showing that it was just, it was variable depending on which contaminant they were looking at. So if you look at the cost to actually upgrade the current central systems, Malcolm Pierney put together some cost estimates that actually showed that to upgrade with nanofiltration, the orange lines show if 100% of water treatment plants were using that technology to be compliant, it would cost $20 billion to do that upgrade. And if you think about most estimates, you usually have to multiply those by 2 or 3 times. So, we're talking somewhere in $20 to $50 billion to be able to do that upgrade. And that would be if we wanted to reduce all of these contaminants that were endocrine disrupting compounds or pharmaceuticals. So it's something to think about. Is that a cost that we really want to do on a central basis, or would it be better to use something like a final barrier where you're just treating 1% and the other 99% is to a different grade, a different utility grade, where some of these things may not be an issue for fighting fires or irrigation. So I've mentioned a couple times less than 1% of municipal water is consumed. I've showed that it may be cost prohibitive for advanced technology, and that money could be used to address higher priority issues. So these are all points of discussion that as we're talking about water conservation and water efficiency, there are things that should be part of that discussion and part of the final barrier concept. Another part is removing most contaminants typically does make the water more aggressive. The more you take out of the water, the more it wants to bring things back into the water. So if we keep treating all of our water to the highest drinking water quality, we're just making it more aggressive, which means that it's harder on our infrastructure. So we're talking about point of use and point of entry devices. In a sense, we're talking about the same types of treatment that you'll see in central treatment, but they're just miniaturized versions that either would go under your sink or for whole house applications. There are several different technologies. I'm not going to go through each of those in depth. Today, I believe Peter Cartwright gave a really good presentation that went into many of them in much more detail. But there are small and large companies involved in point of use and point of entry water treatment. And there are standards and certification programs that provide confidence and credibility to these types of products. So for point of use devices, a few to throw out there, there's pitchers, faucet mount, under sink, countertops. Typically your pitchers and faucet mounts are going to be for consumer type applications where they just want to enhance the taste and odor. They can remove health contaminants as well. But if we're talking about supplementing a central treatment for providing compliance, we're probably going to look towards something like an under the sink or a countertop application. Or if it's globally, we would also want to look at something that's going to be a more robust control system than like a pitcher or a faucet mount, if that's going to be your only treatment option. Whole house treatment, that may be used in some cases where you're talking about where you want the whole house to be supplied, because there may be an inhalation risk. If you're in the shower and you have organic compounds that are volatilizing, then you may want to have those removed at the point of entry of the house versus at the point of consumption. So then you have total safety barriers throughout the house for any of the points of exposure there may be. And these devices are typically inline filters or tank filters. I mentioned that they're certified. We're talking about material certification, so they look at, is it actually adding anything to the water? So these devices, they look at what leaches out of it to make sure that they aren't adding more contaminants to the water than they're trying to remove. Look at structural integrity so that when you put it in a pressure-bearing situation, you're not going to have leaks or floods in a home. They also look at performance in many cases. So you want to look at if it's supposed to remove arsenic, give it a really high challenge of arsenic and see how does it actually remove it. Does it really remove it under worst case situations? Literature claims are on there, so whatever's tested, the literature has to match that. All of the testing is conducted according to national standards. And these national standards are listed here for point of use and point of entry devices. You can see that they're separated out typically by technology type itself. So whether it's a filter, a softener, ultraviolet, reverse osmosis, or distillation. So that way that they're specialized for the technology. And each of these standards are tested and certified according to by accredited certifiers. So ANSI is out there to go to these certifiers on an annual basis, make sure that they're doing what they should be doing, they are testing and certifying appropriately. So now how do we do this? So we're talking about the final barrier concept. Well, it's something that is actually being done in some parts of the world today. So globally, we're talking about the World Health Organization and how they are trying to provide safe water for that 884 million people that are out there still being served unsafe water. So in 2011, they put out guidelines for microbiological performance specifications. I won't go through all of the details of it, but they kind of have a tiered approach so that for countries that have no program in place whatsoever and they're just starting out, they can kind of try to stepwise move up to what would be the most protective type of safeguards for their consumers themselves. So a couple of them are listed here. Typically they're looking at bacteria, viruses, and protozoa, and they have a couple different levels that they go through which increase in stringency in how many log reduction you have to have of each of those microbes. The EPA does have purifier guidelines themselves that also goes over microbiologicals, and in a sense it's pretty much in line with what the World Health Organization is, except it's not a tiered approach, and it is a testing guideline for drinking water treatment units themselves, so you can be tested and certified against their guidelines. Consumers are actually using the final barrier today. I mentioned earlier the MCL versus the MCLG. If you're not familiar, that's the maximum contaminant level, which is enforceable. That's what the EPA sets as the safe level, and that's what municipalities have to comply to. So that's the highest level of contaminant allowed in drinking water, and it's set as close to the maximum contaminant level goal as feasible. So typically it takes into cost and it looks at across the U.S. what is the safe level that feasibly can be done by a municipality. The MCL goal itself is non-enforceable, but it is the point where there is no known or expected risk or health effect at that point to humans. So this is where consumers may want to make that decision of, do I want to have a point of use device myself or point of entry so that I can get to the MCLG, which would be where there are no effects known for humans. So here's a small chart that looks at some of the microbiologicals where the MCLG is 0, but the MCL would have a higher tolerance, so it does allow some. And you can imagine that even just theoretically, you can't typically test 0. There's always some type of threshold or detection limit. but 0 or as close to 0 is what you would have for the goal. These are some of the disinfection byproducts, and you can see some of them, the MCLG is 0 or slightly higher than that, and it's different than the MCL. So again, these are all cases where people may choose to do treatment themselves to try to get to a higher level of water quality. Susceptible populations, they need higher water quality, and it's mostly because they are more likely to become ill or die. They are 10 to 100 times greater mortality rate than those who are not susceptible. And currently, at any one time, there are about 25 to 30% of the US population, and increasing, that are susceptible populations. And the one thing that always gets me is that at some point in your life, everyone is actually considered a susceptible population. Because at some point in your life, you're an infant, or if you're lucky to make it to aged, which they consider as 65 or above, you are considered a susceptible population. For females who are pregnant, that's a susceptible population, and those who are immunocompromised as well. I won't go through all of these populations, but this just kind of breaks down at any one point in time about how many different life stage or health status that people fall in that are considered a susceptible population. Another way that this is actually being used today is the US EPA does allow point of use and point of entry devices for small system compliance. Small systems are 10,000 people or less. And at this point in time, it's something that is not widely used. Only about 8 different states actually have small systems that have point of use or point of entry in use today. However, the EPA is under a congressional mandate for 2012 to actually provide a report on what are the barriers against point of use and point of entry. Because right now, arsenic across the US, there are over 700 small systems that are out of compliance for arsenic. So that means that there are 1.5 or 1.6 million people that are served with higher levels of arsenic than what the MCL is set at today. And right now, the most affordable technology would actually be a point of use or a point of entry device for them to use for compliance. But the point is that a lot of states have barriers set up where, one, they just may not have a program even in place, or maybe they have a program, but they put so many monitoring and sampling restrictions on it that it makes it not feasible for that municipality to actually comply. So Congress is trying to figure out, okay, how do we get beyond all of these restrictions? So what would the final barrier be like tomorrow? Well, it's something that's definitely, it's an emerging paradigm. It's something that's going to continue to grow. So I don't have, a flow chart or an output of what this will look like or should look like. Again, it's something that should be in discussion so we can start to add it to what should it look like for conservation or water efficiencies or even energy efficiency as we move forward. There will continue to be new contaminants that are coming up, whether they're the nitrosamines or EDCs, pharmaceuticals, any of those. There will be stricter laws and regulations, like we saw with arsenic. The MCL came down, and that's the reason why more small systems are out of compliance today than there were 10 years ago. Infrastructure degradation and replacement. We have an aged infrastructure right now, so we have a lot of corrosion and intrusion that's going on in our infrastructure. So these are all reasons that this is going to continue, and final barrier may be a way to overcome that. Innovative technologies are always being developed. So these are things where we're looking at real-time monitoring to make it easier to implement point of use and point of entry. Also looking at external ports to reduce accessibility issues. If you have the real-time monitoring and you use the computers to draw the information, you don't have the accessibility issues. But in the meantime, if we don't get there very quickly, external ports may be a short-term way to be able to get accessibility to make it useful. So these are just some of the things that could be discussed. So as a take-home message, we're really looking at this as a global issue. We have 884 million people that are not being served safe water. And we feel that on a global basis, whether it's point of use or point of entry being used as the only water treatment or it's being used as a supplement to central treatment, it's definitely an emerging paradigm that maximizes delivery of safe drinking water to more people. A few acknowledgments here. Definitely want to say thank you to IAPMO and the World Plumbing Council for having me here today, and to the audience who remained for the end of the 2 days. Thank you very much. And if you have any questions, feel free to ask, or my email address is here as well. Thank you.
Any questions for Pauli?
When you walk into a Circle K, there's a warning about the microwave. When you walk into a gas station, there's a warning, at least in California, about the cancerous fumes, so on and so forth. Isn't there a future sometime possible where the coast-to-coast water distribution system will just say, caveat emptor, or buyer beware, this is not potable, point of use is the most cost-effective and best way to go? What I mean to say is, you say 1% is what's being used. Why doesn't the industry just recommend to everybody? Would it be absolute political suicide to say, hey, get a water treatment system, point of use?
That's what's being said to people who have private wells these days. So, it's something that is done on a small scale for that 15% out there that have a private well like myself. But I think that's a huge concept change. And so it's definitely something that would need to be part of the discussions. And how do we get there? And if we did get there, to just say, yes, this is hygienic grade, but non-potable. How do we get there, and how do we make sure consumers do not freak out about something like that?
We have another question over here.
Yes, my name is Mariana Nicolai. I'm with Sloan Valve, and I want to ask you a question in regards to unregulated substances. 2-3 months ago, I looked actually on water reports from around maybe 10 cities, and besides the fact that they reported what is required by EPA, it's a long list, some of them, they had more detailed reports, some of them just barely passing by. And to me, it's, if a substance is not there, doesn't mean, in the report, it doesn't mean that actually it's not in the water. Do you know if there, it's any proposal maybe at federal level to unify and having a more consistent type of reports from all of these municipalities, regarding, especially for unregulated substances?
I'm aware that they all have to have a consumer confidence report. As far as the requirements for what goes on there, I assume anything that is actually detected would have to be there, but anything that is non-regulated, I don't believe they have any requirements that has to be on the consumer confidence report, and I'm not aware that they're talking about that it has to. There are certain things that are unregulated that they do need to monitor on certain basis, so there are certain regulations that are put out for monitoring, so then EPA can gather data to see if it will help them decide whether it needs to be regulated or not. So that is something that they do monitor them, but it typically takes several years before they come to a decision.
So that means that it's a separate report that the EPA sees it and not the regular public?
It is made public as well, so you can get a hold of the information, but it's typically very hard to find on their enormous website. But you can typically get a hold of that information to find out what are the unregulated compounds that they're looking for, and you can probably find some of that data about what types of occurrences they're finding throughout the U.S.
Okay, thank you.
Jim Kenzel with the American Society of Plumbing Engineers. What I enjoyed about this presentation, and I think we talked about silos yesterday, is that, and I've known WQA for a long time, and I think you've come a long way from the municipal water bad, use our systems to treat that water. And I think there's some barriers between those, the supplier of water and the point of use, point of entry industry that I think still need to be broken down to achieve what you do. And I said, the more we work as partners in the delivery of water, I think the better off we all are, understanding that that last mile that we heard yesterday, or the last barrier, that we can all work together and provide the consumer safe water. But the one thing a question for you, I guess, because I know as long as I've been involved in this environment, and there's wastewater systems that are used in the home to treat wastewater that's directly dumped into the soil or streams, and there's water treatment. And the issue is always the consumer won't maintain the systems. We can't trust the consumer. How do you address that, or what are your thoughts on that?
Well, when it comes down to being a supplement to something like central treatment, then what we're talking about is that there would be either the operators of the central treatment or a collaboration with water treatment professionals, is that they would have some type of accessibility or real-time monitoring. So you know how much is going through them. The certifications for these type of products already set what are the capacities for them. So at what level of, say, arsenic can it handle, and for how long, how many gallons of water. So you would just need to know what is the volume that's going through that device. So a typical monitoring device can do that. So those are things, technologies that need to be incorporated into the devices, which in some places they are being used today, but not very frequently or widely used. So it is something that's available that just needs to be more broadly used so that it can be applied to a central system, so that there can be that monitoring on that type of scale.
Bill Erickson.
Yeah, I want to follow up with Jim, and with my contractor hat on again, it's something that we stay away from because of the liability issue when the consumer or the homeowner fails to change the filter on a timely manner, and then if there is a problem that goes backwards down the spout into the filter, and the filter is found to be bad or contaminated, who put the filter in? We did, we get sued. So that's one of the barriers that I see, is how do you educate the consumer, or how do you tell them, we think you should use this system, but we're not liable for it. User beware, buyer beware. It's kind of a bad, business model to do that, when liability issues are so huge for us.
Well, two things to think about is, one that I mentioned is that if you have that real-time monitoring, you know when to replace those elements. And that's something that in a central system, you would be in control of that, not the consumer. But the other thing, when it gets to liability, there are systems, like for arsenic right now, there are over 700 systems that are out of compliance with arsenic right now. Is that any more of a liability than one of these units going out of compliance? There are things like disinfection byproducts that are out of compliance. So there are certain things that are being dealt with on a liability basis that I think are very similar and would just need to be educated to the consumer so that they would understand it in a similar manner as well. Yes, Joe.
Joe Catrugo, yeah. First of all, before I say a few words, I think I'm generally supportive, and I think there is a role for point-of-use treatment in a number of circumstances. But for one thing, I think Bill is really right that there are serious barriers when one is using point-of-use for compliance purposes. There are legal problems, there are access problems, and the consumer cannot be asked to do the replacement. It has to be managed by the central system.
Correct.
So it's difficult, but I can also say that 5 years ago with NSF, we did a demonstration project for arsenic removal in a small community in California, about 400 residents. It worked great. It was very cost effective. It was about half the cost of central treatment in that community. So it can be done. Now, with that, there are serious cost barriers also. in a small community, I think, maybe about 500 people, it can be cost effective. And I think that's where the biggest opportunity is for compliance. When you get above that size, it is no longer cost effective. It just costs a lot of money. And, you said it would cost $20 billion to upgrade central treatment plants. Well, multiply 100 million homes times $1,000 per unit, and already you're at $100 billion. Plus you have to do the maintenance, the operation, all that sort of thing. So it's really not cost effective when you get above a certain size. Maybe
Actually,
500.
we've been looking at affordability with the congressional report for EPA right now. And when you look at it, a lot of the costs that come in are not actually the device itself. It's more the extra monitoring and sampling that's required, because instead of having one central treatment plant that you monitor, you may have up to 500 treatment units.
That's true.
But again, it looks at, okay, these are certified devices, so is there a level of credibility that they already have? Do we need to test all of them on a quarterly basis or on a monthly basis, like some of them are doing, when a central treatment may only have to look at it on an annual or once every 3-year basis?
You're absolutely right, and I was one of the reviewers on the EPA guidance for point-of-use treatment, and I made exactly all of those comments. And their answer was, and basically what I said is, it makes no sense to treat each unit as an individual treatment plant,
Correct.
because all you really need to do is calibrate it
Right.
to the water quality. And so you will learn once a year, twice a year, once every 2 years, replace it. No need to do any monitoring. It's
Yeah.
just it's
And
ridiculous to monitor.
that's what this whole congressional report
Yeah,
is
well,
trying to
it's-
get over, put it on an
Right.
even playing field, so then we can look at the affordability. Some of the cost estimates were showing that it would be 1/3 the cost for these arsenic systems that are out of compliance.
Yeah,
It would be
yeah.
1/3 the cost to go with a point-of-use system versus central treatment for all of them,
That's
if
right.
the monitoring and sampling was under control and logical
Exactly,
Yep.
for small systems.
for small systems.
But when you get bigger, then it doesn't work anymore. But anyway, I do agree that there should be a different paradigm for providing safe drinking water to the country than we have today. Central treatment only, and then voluntary point of use, which some people do primarily due to taste, according to the statistics. So there are other options. Delivered bottled water, for example, is a cost-effective option in small communities. Point of use. Point of entry usually is not cost-effective
Correct.
because it's treating all the water. The value of point of use is it's only treating that 1% that people drink. So anyway, it's a great issue. I think it's well worth exploring. There are a lot of issues that have been dealt with, and I think there are niches that can be developed for it. But I just want to say one more thing. I don't think we need to kind of dwell on this issue of, the last nanogram of a contaminant in water. And I'll give you a great example. Nitrosamines, which are carcinogens, right? They're in water in some places, parts per trillion.
Right.
However, unfortunately, we manufacture 99.9% of our total exposure to nitrosamines, endogenous manufacture. So that 1 or 2 or 3 nanograms in the water doesn't mean a thing. So you got to look at the science on these things.
Ed Ocean.
Yeah, Pauli, very interesting presentation. Maybe I missed it, but do any of the kinds of point-of-use products that you identified have now or offer the capability of some self-diagnostic capability that would allow for remote monitoring and verification of their performance as opposed to on-site visits, which of course would be much more costly?
There are some unique systems, not for compliance, but maybe for a commercial application, where they are using real-time monitoring and they're using computers to be able to access that information. But they're very small scale. It's nothing that has been implemented for, say, a utility on a compliance basis that I'm aware of.
I was just going to observe that as more utilities go to AMI systems with the ability to upload their own meter data, that collection system is there in place that could potentially do double duty for other remote data acquisition.
Definitely. When you mentioned that this morning, I completely keyed on that, and I think that is an area that could be used for the same type of concept.
Any more questions for Pauli? Thank you very much.
Thank you.